Good morning everyone. Today I will demonstrate an experiment on frequency modulation using the ST2204 trainer module. Frequency modulation is a technique where the frequency of a carrier wave is varied in proportion to the instantaneous amplitude of the modulating signal. It is widely used in telecommunication, particularly in radio broadcasting, due to its advantages like better noise immunity and higher sound quality compared to amplitude modulation. The ST2204 module allows us to explore FM practically by generating and analyzing modulated signal. During this experiment, I will generate an FM signal by modulating a carrier signal with a given message signal and observe the waveform using the oscilloscope. Or this experiment provides insight into how frequency modulation is implemented and its real-world application in communication system. Let's proceed. Let me explain the key concept using the diagrams. The first graph represents a modulating signal, which is typically low frequency signal such as an audio signal. As you can see, the amplitude of the signal varies smoothly over time. This variation amplitude will control the frequency of the carrier wave during frequency modulation. The second graph shows the carrier wave, which is a high frequency signal with constant amplitude. In frequency modulation, the frequency of this carrier wave is altered based on the amplitude of the modulating signal. The third graph illustrates the FM signal. Notice how the frequency of the carrier wave changes. It increases when the amplitude of the modulating signal is high and decreases when the amplitude is low. However, the amplitude of the frequency modulating signal remains constant throughout. The bottom diagram shows a voltage control oscillator VCO. The modulated signal is fed into the VCO, which controls the carrier wave's frequency. As a result, the output of the VCO is the FM signal, where the frequency varies in accordance with the input modulated signal. So let's begin with the first experiment. Here we have the function generator. We are using the function generator of this trainer itself. We are not using the external function generator. So the frequency is about 1 kilohertz and amplitude about 0.2 voltage peak to peak. In VCO2, the block 2, we are the level about 2 VPP frequency selection switch on 15 kilohertz and frequency potentiometer at the center. Now we have connected the output to the oscilloscope of VCO2, and here you can see the graph. Next experiment, I am going to explain some more important keywords by the diagrams. So here is a PLL, phase lock loop. A PLL is a control system that synchronizes an output signal with a reference signal in both phase and frequency. It consists of three main blocks: a phase detector, low pass filter, VCO, voltage control oscillator. The phase detector compares the phase of the input reference signal with the output signal and generates an error signal proportional to the phase difference. The error signal passes through an active low pass filter which removes high frequency noise, leaving a smooth control signal. Next, this control signal adjusts the frequency of the VCO, which generates the output signal. As a feedback system, the PLL continues aligns the output signal with the reference. And here the graph shows the frequency response of the low pass filter and a combined low pass filter, high pass filter, illustrating how specific frequencies are passed and attenuated. So let's start with the experiment. Here we have frequency generator, frequency at 10 kilohertz and amplitude of 0.5 volt. So frequency of 1 megahertz and amplitude at maximum in VCO1. We have connected the frequency generator to VCO and output of VCO to PLL input. Here, output of PLL detector to the input of low pass filter, and we have switched it on. The button is in the on position in PLL detector. Now observe the output of low pass filter circuit while adjusting the frequency. Adjust the potentiometer in the PLL detector block. You can see the graph here. Hopefully you have liked this video on the topic of FM communication trainer ST2204. Thank you for watching this video.